Now we will discuss about perpendicular axis theorem. Our second theorem is perpendicular axis theorem. Axis theorem. So what is perpendicular axis theorem? If this is any geometrical body, this is any geometrical body. Now, let this be the x-axis passing through the plane, and moment of inertia of this body about the x-axis is Ix, and over the same plane, see here, x-axis is passing over the plane of the body. Similarly, y-axis also passing over the plane of the body. And moment of inertia of the body about the y-axis is Iy. What is the mass of the body? M. Now see here, this plane lies in xy. Plane of the body lies in xy plane. That is, x-axis lies in the plane of the body, y-axis lies in the plane of the body, and z-axis is perpendicular over this plane, like this, and inward z-axis is minus z cap, perpendicular to the plane. Z-axis is perpendicular to the plane. This is z-axis, and moment of inertia of the body about the z-axis is Ij. Now, according to perpendicular axis theorem, the moment of inertia of the body about the z-axis will be the sum of moment of inertia of the body about the x-axis and moment of inertia of the body about the y-axis. What is the statement here? According to perpendicular axis theorem, if two axes x and y, if two axes lies in the plane of the body, then the sum of moment of inertia about these two axes will be equals to moment of inertia of the body about the axis which is perpendicular to the plane. Here. Write down, according to this theorem, the sum of moment of inertia, about two perpendicular axes lying on the plane. Here two axes which is lying on the plane are x and y, and these two are perpendicular lying on the plane, will be equals to the moment of inertia of the body about the axis which is perpendicular to the plane, of the body. Now you see it. So Ix plus Iy. Let us again Try to understand this theorem. This is a geometrical step. Body and over the plane of the body, x-axis and y-axis lies. Moment of inertia about the x-axis is ix, and moment of inertia of the same body about the y-axis is iy. Now, perpendicular to the plane of the body is z-axis, and the moment of inertia about the z-axis of this body will be the sum of moment of inertia of the body about the x-axis and moment of inertia of the body about the y-axis. See here, beta, I'm showing you one very small example that will prove this theorem. See here. Let this be the x-axis. This is the x-axis. This is the origin. This is x-axis. And body is here. This is y-axis. So this distance is y-axis. This is y coordinate. What is the mass of the body? M. Now, if we determine the moment of inertia of the body of mass m about the x-axis, it will rotate like this, about this. And what is the perpendicular distance? Y. So ix is equals to my square. Now, this distance is x. This x coordinate. Now, if the body rotates around the y-axis, then its moment of inertia about the y-axis will be mx square. Now, if you sum up these two, ix plus iy, then it will be like this, m into x square plus y square. Now you see, this is x square plus y square, this is what z square, and see here, this is x-axis, this is y-axis, this is z-axis. Z-axis. So, and this is the perpendicular distance from the z-axis. So this is what z-axis is perpendicular to the plane of these two body. And this is what, this is the perpendicular distance from the, this is what, this is the perpendicular distance from the r square. You write this as a r square and write down here r is the perpendicular distance from z-axis. Perpendicular distance from z-axis. Z-axis. So this will be equal to r square, and r square is the perpendicular distance from z-axis. So this is the moment of inertia of the body about the z-axis. This is equals to I z. This is equal to I z. Hence proof ix plus iy is equals to iz. This is known as perpendicular axis theorem. Now let us solve some example that is related with the perpendicular axis theorem. That is related with the perpendicular axis theorem. This is a ring. If the moment of inertia about the x-axis passing through the plane is known, this is ring. This is what? A ring. What is the mass of the ring? M. And what is the radius of the ring? R. If it is given that moment of inertia of the ring about the diametric axis is mr square by 2, mr square by 2, then determine the moment of inertia. This is x-axis, this is y-axis, but perpendicular to the plane is z-axis. Z-axis. Determine moment of inertia of the body about the z-axis. Now see here, since ix and iy lies in the same plane and both are passing along the diametric, both are passing diametrically. We have already learned just in our previous classes that moment of inertia of the ring about the diametric axis is mr square by 2. and this is equals to Iz about the axis which is perpendicular to the plane. According to what? According to perpendicular axis theorem. PR, perpendicular axis theorem. Now, mr square by 2, mr square by 2, this will become mr square. That is about the z axis, moment of inertia is mr square. We have already derived this formula, but we should know the application of this theorem because it will be very much helpful for determining the moment of inertia of different conditions. Now, dear all of you, yes, now all of you, we will discuss about the moment of inertia of solid sphere. Moment of inertia of solid sphere. How we can determine the moment of inertia of solid sphere? You see here, if you take a spherical potato and you start to cut like this, you will get chips. With a knife, if you cut like this, you will get several chips. What is the shape of the chips? Disc, circular disc. All this, but the disc which lies here, its radius will be 0. Now see here, the radius goes on increasing. It will be here r, less than r, decreasing, again less. So the radius of all this disc will be different. Now we have already derived the formula of moment of inertia of this about the axis passing through its center. And what is the formula? Half into mass of the disk into square of the radius, half mr square. Now, if you determine the moment of inertia of the single disk and we sum up, integrate, then we can determine the moment of inertia of whole such a disk. Then if we sum up the moment of inertia of whole such a disk, then we will get the moment of inertia of solid sphere. So, by using moment of inertia of the disk, we will derive the formula moment of inertia of the solid sphere. Now, see how we will determine the moment of inertia of solid sphere. Take a sphere. Take a solid sphere of mass m and radius r. And radius r. This is the axis passing through its center. This is the axis passing through its center. This is the center. And this is the axis. Now, this is radius r. From here you moved. From here you move to distance y. Now what is this distance? X. You further move to dy and cut a small disc. This is the shaded figure. This is the shaded figure. This length is x. This distance is y. And what is the distance? R. So this is right angle triangle. We can write x square plus y square is equal to r square. X square plus y square is equal to r square. For triangle, which triangle? O A B. For triangle, for triangle OAB. Now you see it. X square plus y square is equals to this. Now, what is the value of x square? R square minus y square, or x is equals to root under r square minus y square. This is equation number 1. Now you see here, what is the thickness of the disk? The thickness of the disk is dy. This is the dy. And how this disk obtained? If we cut, this is solid sphere like this. We will get one disk, that is shaded portion. Cut the solid sphere as a solid sphere into several disks. Take one disk, whose mass is, what is the mass? Is dm. Why the total mass is m? So mass of very small portion of this solid sphere is dm. And its radius is, what is the radius of the disk? And radius is, what is the radius? X. Because this is the axis and we rotate like this. What is the radius? And the radius is x. Now, moment of inertia, all of you see, now, moment of inertia of this shaded disk. About this axis which is passing through its center. Di. Why? Because very small portion. We have to determine the moment of inertia due to whole solid sphere. And due to whole solid sphere is I. And since we have taken a very small portion of the mass of the solid sphere, so moment of inertia of this small portion is di. Now, moment of inertia of this, we know the formula, half into mass into square of radius. What is the radius of this circular disc? X square. And what is the value of x square? X square is equal to half. What is the mass? First tell me mass. Total mass of the solid sphere is m. Distributed over its volume. What is the volume of the sphere? 4 by 3 pi r cube. 4 by 3 pi r cube. Mass per unit volume into, that is density, into volume of this portion. What is the volume of this portion? You know, disk is in the shape. If you compress a solid cylinder, it will form a disk. Now, what is the volume of the cylinder? Pi r square. What is the radius of this disk? Into what is the height? Dy. Now, you cut this pi cancel out. Now, half m and half m x square is into x square. Now, we have to integrate this equation. 3 comes here. This 4 to 8, 3 upon 8. Di is equals to 3 upon 8. Now, r cube x square into x square, m is here. This is x to the power 4 into x to the power 4. Now, in place of x square, what you can write? In place of x square, what you can write? See here, x to the power 4 into dy, since these are two different variables. So in place of x square, Put s square here, this will be also become a square. Now x to the power 4 di is equals to 3m by 8r cube. In place of x to the power 4, we can write r square minus y square whole square. Because why? Because r square is equal to x square x to the power 4. Then again square this side, it will become like this. And now here only one variable is there. Now you can easily integrate this equation. And what is the value of variable for covering whole disk? From here to here is r, and here to here is minus r. So you take the limit, then you cover whole disk. What is the limit of integration? Minus r to plus r. What is the limit of integration? Minus r into plus r. Now, see here, beta, all of you. Yes. Now, to determine the moment of inertia of whole sphere, we have to integrate this equation. What is this equation? Second. Now, right here. Now, you know this. What if you cut the solid sphere into several disks? Its coordinates from here to here is minus r. We will minus r to plus r. Here to here it is plus r. We will cover all such a disk. Now, by integrating equation 2, we get the moment of inertia of solid sphere. Now you see here how we will integrate. Integration of di is I. We will get I. Now 3m upon 8r cube. This is constant. 3m upon 8r cube. Now you see here, take the squaring of this one and multiply it with dy. What is the squaring of this? A square, a minus b ka whole square, a square plus b square y to the power 4 minus 2ab into dy. Integrate this. Minus r to plus r. We will get the desired formula. We will get desired formula moment of inertia of the solid sphere. Now, what is the integration? 3m by 8r cube. Now you see r to the power 4 into dy. R to the power 4 into dy. Keep r to the power 4 constant minus r to plus r. Solve it. Now y to the power 4 into dy, both are variable. Put integration sign here. Minus r to plus r is the limit. Now minus 2 to constant r square constant y into dy. Take the variable terms here into dy. What is the limit of integration? Minus r to plus r. Now if you solve this whole equation, you will get moment of inertia is equals to solid as for moment of inertia of solid sphere is 2 by 5 mr square. Now how you will solve? Let us see again. What is the final derivation you will get? 2 by 5 mr square. 2 by 5 mr square. Now you will see here 3m by 8r cube. You will see what is the integration dy. Dy is y, upper limit r minus lower limit minus r. Minus plus r minus r. R to the 4. Dy is y, upper limit is plus r, lower limit is minus r. R minus minus r, that is 2r. R to the power 4 into 2r. Now plus y to the power 4 into dy, 4, it will be 5 upon 5. What is the limit? Minus r2 plus r. It will be r to the power 5 minus r to the power 5. It will be 2r to the power 5 upon 5, like this. Now, see here, y to the power 4. What is the power 4? 4 plus 1, 5, and this power will come here. Again, put constant sign here. Plus r, what is the limit? Upper limit plus r to the power 5, upper limit minus lower limit minus r to the power 5. It will be minus and minus plus. So r to the power 5 plus r to the power 5, 2r to the power 5 minus 2r square. What is the integration of this one? Minus and is 2r square. What is the integration? What 2 power is there? It will be 3 upon 3. What is the limit? Minus r2 plus r. Again, power r cube minus r cube, that is 2r cube. It will be 2r cube. 2r square into 2r cube upon 3. Now solve this one into 3m by 8r cube. Now by solving this one, you will derive this formula. You will find this formula. You can solve this one. Now what is the final formula for moment of inertia of solid sphere? 2 by 5 m r square. Take the LCM like this one. By 1, 5 3s are 15, 15, this is 30, r to the power 5 plus this is 6 r to the power 5 minus 40, and you just solve everything. You will get the desired answer. That's 2 by 5 m r square. Your answer will be.